So this is a rectangle problem. It involves a rectangle. Now, sometimes when students are doing these word problems or application problems, I think they treat it like ripping off, a Band-Aid, just hurry and get it over with kind of thing. But these problems aren't quick. You have to really, sometimes they are, but you have to really think about it. You have to spend some time setting up the problem and reading and figuring out what's going on, and then get the equation. So, a little bit of patience and hopefully some positive vibes. Okay, Mario wants to put a fence around the pool in his backyard. Since one side is adjacent to the house, he will only need to fence 3 sides. So, okay, so he has a house. Here's his house. And then he's going to put a fence, he's going to put a fence along here and along here and along here because there's a swimming pool. There's the pool. Okay, so take a little time, draw the picture. All right. One side is adjacent to the house. He'll only need to fence 3 sides. Okay, so my fence is in green there. There are 2 long sides, and the one shorter side is parallel to the house. Okay, so scrap that picture because that's not really accurate. Okay, let's try again. Here's the house, and then we've got 2 long sides, and then one shorter side. So the pool must be going, like there's, I don't know if that's a swimming pool, but anyway, so it looks something like that. Okay, now that's a better picture than what's going on. Okay, so we've got the picture. He needs 155 feet of fencing to enclose the pool. Okay, so you're gonna need, all 3 sides that are in green to add up to 155. Okay, keep that in mind. The length of the long side, okay, is 10 feet less than twice the width. Okay, so it's gonna, if I count this as the width, then the long side is 10 feet less than twice the width. Okay, so let's read it again. The length of the long side is 10 feet less than twice the width. 10 feet less than twice the width. Okay, now one of my little issues with this, it's a textbook issue. They didn't really say what the width was. I would have said is 10 feet less than the shorter side because that's how they had described it. But I'll just cut them a break and assume that the width was the shorter side and the length was the longer side. Okay, so what do we need? We need to find the length and width of the pool area to be enclosed. I don't know if I would use 2 equations here, but you could. So I'll show you how to do that. You could say 2 lengths, so twice the length, plus 1 width has to equal 155. So he needs 155 feet of fencing, and he's going to have to go 2 of the long ones and then 1 of the shorter ones. Okay. Now, what do we know? Well, we know the length is, I made another equation there, is twice the width minus 10. So I can substitute that in, substitution problem, 2w minus 10 plus w. So I'm taking this equation right here and I'm substituting it into the other equation. Okay, well now it's just an equation in 1 variable, so I can just distribute 4w minus 20 plus w. I think I forgot to make 2 equations on the last few problems because I was all interested in the angle part of it and explaining that. But, you could have done those with 2 equations as well. All right, so did I distribute right? Yeah, I think that looks okay. 5w minus 20 equals 155. Add the 20. 5w equals 175. Divide by 5. Run out of room. W, so that shorter side, 335. I'm just trying to divide that in my head real quick. So yeah, that looks right. So 35 feet, I think we were in feet, weren't we? For the width. It says find the length and the width of the pool area. Okay, so the width, 35 feet. And I would just put FT for feet. And then the length. Okay, well, I'll have to figure out the length. So let me do that. The length is going to be twice the width minus 10. So what's that? 70 minus 10, which is 60. So I'll say the length is 60. Feet. Okay. Now you can check, does that add up if you take two long sides, that's 120, plus the 35, does that add up to 155? Yeah, so I think we're good.